You know what's really cool? Have you ever been in line at the theme park and you wander through all of the lines and then it opens another door and there's a whole nother room of lines and and you know when you finally see the ride and you're like, isn't this exciting? You're next. You know what's really cool? We're next. We get to do this. Or if you're in the ADD room, we get to do this. We get to talk about .NET testing best practices. This is going to be really cool. Here's the part where I tell you I am definitely going to post the slides on my site tonight. And in this talk, there are no slides. It's only live demos. So, no slides. Woo! Here we're going to talk about .NET testing best practices. The code is already online. Here's our start folder where we're going to begin. And here's our done folder, the completed solution. And so you can download this code right now and follow along. This URL, github.com/robrich, that might be a little long. Let's head over to robrich.org, robrich.org, and we'll click on presentations. Here's .NET testing best practices right here at the top, and you can link to the code. It is online right now. While we're here on robrich.org, let's click on About Me, and we'll see some of the things that I've done recently. Both Microsoft and Docker have given me some awards for some of the things that I've done. I'm a friend of Redgate, Cypress ambassador. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Oslo or wherever you traveled from, find me here at the conference or on any of the socials, and let's get a Give Camp in your neighborhood too. I've gotten to write some books, Pro Microservices and .NET 6. That was really fun. Still relevant today. One of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments in the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. And if you'd like a .NET, no, I'm just kidding. So let's talk about .NET testing. So I popped open this solution here at the start folder inside of Visual Studio. And let's take a look at it. Now this is a sample from an IoT solution. And I've got this light switcher, and I've got this motion sensor, this light actuator. And this actuate lights, this is the function that we want to test. Now this function's purpose is to decide whether we should turn on or turn off the lights. And it's not a stateful system, so we might choose to turn on the lights while they're already on. That's okay. And so we want to test this. We take in if the motion was detected, and we either turn on or turn off the lights. And then we've got a get time period that decides what period of time it is. Let's see if we can test this. Now our first step is to go add a test project. So let's come in here and we will say add new project. Now in this case I'm going to choose an XUnit test project, but we could definitely choose NUnit or MS test. So I'll say I would like XUnit, and it will filter down to the XUnit test project. I want to make sure that I pick the C# XUnit test project. There was a demo not too long ago where I picked VB, and that was a very different demo. So I'll pick the XUnit test project, and I actually created it. It's right here. I added a few dependencies. I'll come in here to manage NuGet packages, and I did choose to install two new things. I chose to install Fluent Assertions and MOQ. Actually, MOQ AutoMock. So Fluent Assertions is actually really cool. Let's come in here now and start to write a hello world test. So I'm going to say add new item. And this one will be hello world.cs. It will populate a bunch of stuff for me. Thank you. I'll make this public. File scope namespaces are amazing. And I will say this is a fact. Now in XUnit it's called fact. In NUnit and MS test we'll put test on there. I kind of like test better, but fact works. Public void hello test. And I want to say assert dot true. What is some condition? Assert dot equal true and false. Okay, so I've got this assertion, and now I can run my tests. I'll come here under the test menu, and I'll choose Test Explorer, and that will pop up this window, which, yeah, that's frightfully small. But I can see that I've got my hello test. I'll run all tests, and in this case, this test is going to fail. Okay, so bool actual equals true, bool expected equals 7. Nope, I'm going to make that int and int. And so, of course, I put actual and expected here, and I can rerun my test. And I love this test output because it tells me not only what was it expecting and what was the actual, but I can see what line it was. And so it says expected 5 but got 7. I spent a really long time debugging this because it said expected 5. And so I debugged it, I stepped through it, and I got 5. I'm like, you expect 5 and I got 5. What did I, oh, I actually flipped expected and actual. Expected should be first and actual second. Oh wait, no, I think I got it right the first time. I think actual should be first and expected should, I hate that game. And thus fluent assertions. What fluent assertions does really good is we can say actual.should.be expected. And I never have to confuse those again. Very nice. Now here, we're going to separate this out actually into the arrange, act, assert pattern. So let's say arrange, and then act, and assert. And I see I have expected and actual backwards again. Let's do that. And so now we have that arrange, act, assert pattern where we set up the condition that we want to do, and then we do some stuff, and then we validate that what we expected to happen is actually happening. So now we can run this test again. Let's run tests, and we'll see that this test now passes. Run test. Oh, I guess if I make them actually pass, then it'll pass. There we go. Run tests. And now we'll see that it goes green. Cool. So we got a feel for how we might use the arrange, act, assert pattern, how we can set up our test project. Now let's come back here and take a look at the code that we want to look at. Okay, what are the scenarios that we want to test? Well, we want to test to see if motion was detected, and so we'll want a true and a false case there. It looks like if motion was detected, it will update the time, and if not, then it won't. We want to see if motion was detected and it's dark, then we should turn on. If motion was detected but it's light, then we won't turn on. It looks like if motion was not detected in the last little bit, it will turn off. Or if it's light, it will also turn off. So let's create a bunch of tests. So I'm going to create a new file, add new item, and I'm going to call this add new item, light actuator underscore actuate lights underscore tests. Now I've chosen to name this class very specifically so that just at a moment's glance, I can know which class I'm testing and also which method I'm testing. And so that can be really great. Public, file scope namespaces are awesome, global usings are awesome. And so here is a fact. I want to say public void motion detected set current date. That's one of our tests. Now it would be really easy for me to leave this method blank. But now that test will pass. That's not what we expect. So let's very specifically say throw new argument not implemented exception. And now I know that I haven't implemented that test. That test will fail until I'm ready to set it up. Okay, so motion not detected don't set current date. Cool. We had one where we said day motion detected and day turn on. But actually, if we look at this, it says, well, motion detected and dark turn on. There's two conditions here. Motion detected and dark. So we might want to say and night, and then evening. Wouldn't it be cool if we could instead just say pass in a parameter to our test? Well, let's do that. Let's say motion detected and night turn on. I'm going to change this from a fact to a theory, and I'm going to pass in inline data. And I'm going to say morning, I want you to not turn on, and afternoon, I want you to not turn on, and evening, I do want you to turn on, and night, I also want you to turn on. So I'll say time of day and expected. And now I've got parameters into my test. Now we still haven't implemented that test, but that's really cool. That allows us to be able to create much more terse tests that flex lots of different conditions. So we'll do that, and we'll do similar things with motion not detected and night turn off. Now, in the morning, I want it to be true. In the afternoon, I want it to be true. In the evening, I want it to be false. And at night, I want it to be false. Cool. Now, we'll probably also want to create some tests for the time period. So I'll leave myself a little note to do time period tests. We'll come back to those if we have a minute. Let's start to implement this. Well, yeah, do I want to refactor this into one test and pass in parameters? Yeah, maybe, but let's start simple instead. Okay, so arrange, act, assert, and let's kind of TDD this test. Well, that's kind of cool. What are we going to act? Well, I want to say light actuator equals new light actuator actuate lights, and I'm going to pass in motion detected, and then I'm going to say date time last motion time equals light actuator.last motion time, and I want to assert that last motion time dot should dot be not be start time. And so now I know that I have two parameters that I need to put into this test. So I want to say bool motion detected is true, and date time start time equals new date time 2000 not now. I'm going to make that comment to say the value isn't really important. It just needs to not be now enough that it will identify that. Cool. So we do need to pass in that start time. Let's say light actuator dot last motion time equals start time. Cool. So let's fire up our test, and we see that we have a compile error. Now looking at our code, we see that this light actuator does have an interface. That's cool. And the interface only has this actuate lights method. That's perfect. So in our production code, when we call that light actuator, then everything's fine. But for the purpose of our test, we really need access to this last motion time. So I'm going to make this public, but I'm also going to make a comment that says public for testing, not part of interface. Because I'm sure some helpful developer is coming to come behind me and go, oh, this isn't part of the interface. Here, let me add it. So let me just document that that's intentionally not part of the interface. It's just part of the public piece for testing. Now, I could definitely make it protected or friends visible to. That adds a level of complexity I don't want to take on right now. So here's my test, and let's take a look at that test in the Test Explorer, and we'll run all the tests. Now, one thing that we could choose to do here is we could choose to say, run tests after build. Oh, I got a build fail. Oh, haha, string, bool. Yeah, data types are a thing. Build. That worked. Let's run our tests again. Here in this menu, we have an option that says run tests after build. Now, there is a feature in Enterprise Visual Studio that says live unit testing. This is not that. But if our tests run fast enough, we could choose to just run them all the time. And whenever our tests run, or whenever our build runs, then our tests run, and we can validate that our code is as we expect. Now, of course, we have a bunch of failing tests because we haven't implemented them. But it looks like we also, and this test actually went red as well. So let's take a look at what we did. Motion detected. I'm going to set a breakpoint right here. And I'm going to, in the same way that we ran tests previously, let's debug tests. I like that we can just walk through our thing and get a feel for how this works. Okay, so F11 to step in, F10. Motion is detected is true, and so last motion time is time, which is right now. And so we come in here, and the exception that we get is something completely irrelevant to our test. The fact that we didn't initialize a light switcher. How does that have to deal with me testing to see if my light is working? Well, and I'm still throwing that exception at the end. What's really cool is, let's go quick implement this other method, because that'll be fun. We want to say that motion is not detected and should be the start time. So how do we get that to work? Let's run our tests again. We'll see that one now goes green. Well, this light actuator singleton thing is kind of getting in our way. It's creating this singleton so that we could do it, but we're not actually calling init with a light switcher because we don't actually have a real light switcher in our test. And so I'm just going to yank out this whole static class thing. Let's pull the interface out here, and let's make this an instance class, and it can implement light switcher, and let's implement that interface. That looks good. And we'll turn on as well. And so we did need to change our production code, but we did it in a really elegant way to be able to make this more testable. So let's inject an light switcher. Light switcher. Default constructors in .NET 8 are amazing. Create and assign field light switcher. Well, I don't need to do that anymore because, well, that default constructor just did that for me. So I'm going to grab this and just say this is light switcher, and our code works great. Well, there's one more place that we do need to update. The production code calls lightswitcher.init, and so now we want to say light switcher equals new light switcher. Oh, new light switcher instance. And we want to pass that light switcher instance in here. new light switcher instance is just going to take in, implement the light switcher, and away we go. Oh, to that end, we probably don't need this fake implementation. We already have one somewhere else. Great. Let's build this and make sure our tests still pass. There is no argument that, oh, I need to create var light switcher equals new light switcher instance. Oh, wait, now I'm going to actually turn on a light. Maybe I could create a fake light switcher. So let's say public class fake light switcher implements light switcher, and that was kind of a long way to go. Let's instead use a mock here. I want to go reach into MOQ, and we will go create a light switcher right here. And so we can create a new mock of some interface, and it will just implement the details, returning default values. Now, in this case, we don't care about what the actual implementation is, so let's just say mock of light switcher equals new light switcher, and now we can pass in light switcher mock dot instance. If we're using NSubstitute or dot object, if we're using NSubstitute instead of MOQ, then we just pass in the object itself instead of dot object. Cool. So we've got this mock set up here. Let's come back into this test and touch that up too. And then we can run our tests, and we can see that now both of our tests go green. Well, we still have failing tests downstream, but these two tests will go green. Nice. Okay. If you pass in true, then we'll set the date. And if you pass in false, then we won't set the date. And from now on, we can validate that that behavior is as we expect. Cool. So next up, let's take a look at this. Now, part of it is motion detected. So actually, let's come in here with arrange, act, assert. And what is my act? Well, we've got some act stuff going on here. That's cool. I need a light switcher mock. Now, I need to pass in motion detected, and I think motion detected is true. So bool motion detected equals true. Nice. I don't care what last motion time is. I just need it to, based on this time period, turn it on. Okay. So I need to somehow say light actuator dot time of day equals time of day. Well, that's not quite going to work, but we're on the right track. And then we want to say assert that light switcher mock dot time of turn on called. Now that doesn't work either, but we're kind of moving in the right direction. We kind of got the feel of what we want to do here. So let's create then, we've got this light switcher mock, and we want to take a little bit more control over this light switcher mock to be able to know when the turn on method was called. Okay, so light switcher mock dot setup, and let's say for that mock m dot turn on. When the turn on is called, then we want to say we want to call this callback that says turned on or actual equals true. That's perfect. And so let's create this bool actual turn on. It's false. So that's pretty cool. We can say expect actual turn on dot should be expected. Very nice. And so now we were able to just grab that fake thing and know when it was called, because it's going to call this callback that will set our flag. Perfect. Now, how do we set the time of day? Well, we can set the time of day based on this get time period, and it passes in a date time, which is set to now. That's kind of a long way to go. Really, what I want to know is, how do I control the results of this method? Ooh, I want to control the results of this method passing in a thing that's very specific. So instead of making this a private method inside this class, what if we instead create a public class time period helper, and this is a public string get time period, and then let's create an interface for that. Extract interface. Oh, there it is. Extract interface. Now, maybe moving it to its own file would be a good idea, but let's just put it right here. Instead, get time period. So now let's take this time period helper, and we'll pass it in here, time period helper. And so now instead of calling that private method, let's call time period helper to get it instead. Cool. Now, if we build our production system, we did refactor it a little bit, but this was kind of a private experience between these two. So the only thing that I have to do now here in my program is just make sure that I pass in that time period helper. Time period helper. And so I need an time period helper. I am so tired of creating these things. Can we dependency injection this? Dependency injection is built into .NET now, so let's do that here with this console app. Now, if I was to make a new console app, it would just have this built in, but I can go grab this dependency injection, Microsoft Extensions dependency injection, and then I can create a new service collection, that IOC container, and then just do it. So let's actually do that. I'm going to go find this here in our application. Nope, right here, program.cs. I'm going to say var IOC equals new service collection. I'm going to say var app equals IOC.build. And then I can say, while true, app.do the stuff. Well, in this case, it just kind of loops through. Let me go grab a var light controller equals app.get required service of type light controller, and it will just figure out all the dependencies. So I no longer need any of that. Now I do need to rig up my dependencies, so let's go grab those and set them here. Oh, let me call this services. Hey, that's pretty cool. I just used IOC dependency injection inside of my console app. Now I don't have to worry about, do I have another dependency? Do I need to pass it into all the things? And now my production code just works. Cool. Now let's come back to our tests and build them. Now I have to play the IOC game over here too. Is there a dependency injection thing that I could use here? Well, that's what's really cool here with the AutoMucker, is it is a dependency injection framework for tests. Now the cool part is I can provide the implementations that I care about, but if it's a dependency that I don't care about, I can just say, hey, AutoMucker, go figure it out. Go make me a mock and pass it in. I don't care. So let's do that. Let's come back into our test here, and we will say var IOC equals new auto mocker. And then here I can say I would like IOC.create instance of type light actuator, and it will just figure out the dependencies. In this case, there are mocks. Maybe, I don't care. This test is just about that first piece. So let's do that in this test, and let's do that in this test as well. But in this test, I actually do want to set up this light switcher mock. So let's go grab that and put it here. Oh, I do need to set up this one too. Excellent. I do care about this mock. And so this light switcher mock, let me just say, hey, IOC, can you get a mock, please, that is of type iLight switcher? And it'll say, sure. If you've given me one before, I'll hand you back that one. If there wasn't one, I'll just go invent one for you. That's cool. So now I can say, I would like a mock time period helper. Hey, IOC, can you go grab me one of those? Thank you. Time period helper.setup. Hey, when you call get time period, let me actually nuke that. Thank you, GitHub Copilot. But you're spoiling the ending. Time period. I want you to return the time of day. So that's how I inject the time of day into this time period helper. Now, I do need to pass a parameter here, but it's a date time, and I'm like, I don't know what date time I'm going to pass in. It's going to be datetime.now-ish. So I'm going to say it.isAny date time. And now I can go grab that time period helper and set it up to return the results. Cool. So let's run this test. Run test. And now we can see that it's going to go inject the time of day that we need and then automatically call our callback. Watching this debug is just amazing. It did go green, but let's set up a breakpoint right here and let's debug it because it is just so fun to watch. Okay, so I set up F11 to jump into my light actuator. Was motion detected? Yes, it was. So I'm going to set last motion time. Now I need to get my time period. Let's F11 to step into it. And it actually comes over here to return this time of day. That's cool. So I have that time period. In this case, it was afternoon. And so should I turn it on? Nope. That's cool. Let's push play and see if we get to our next case. F11, motion is detected. What is our time of day? This time of day is morning. That one doesn't turn it on. That's great. Let's do this again. And now I have my time period that is night. Night is dark, so I should turn this on. I'm going to F11 to step into it. And where I get to is this callback that sets my did I get called thing. That's awesome. So I'm now setting this flag, F10. As I walk out of this code, now that actual turn on is set, so it should be true, expected is true, and now my test goes green. That's cool. So we did have to refactor our code a little bit, but we were able to use dependency injection both in our production code and in our tests to make our tests a lot simpler in ways that we didn't need to worry about. That's cool. So let's come back in here and grab our test. Motion not detected and night and day turn off. Now in this case, motion is not detected. If motion was detected, then we would end up in this thing. So motion is not detected. And so Let's see, last motion time needs to be greater than 1 minute. So that means I do need to set up a bool start time equals new date time. More than a minute ago. We will set that here in our light actuator. Haha, it's not a bool. Okay, and now we're not grabbing the turn on, but rather the turn off. So I'm going to rename this actual turn on to actual turn off. And let's run this test. Run tests. Let's take a look at our test explorer and see how that's going. Ooh, we got an error. Expected actual turn off to be false, but got true. Let's see if we can debug that one. I'm going to set up the debugger right here, and let's debug this test. Debug test. F11. Motion was not detected, so that was that. What is our time period? Our time period is afternoon. And time period is morning or afternoon. Oh, if it was long enough, then it was, I got that condition wrong. So actually, this one needs to be less than a minute ago. Let's say date time dot now dot subtract or add seconds -1. That's definitely not going to be too far away. We'll run our tests, and now we've got passing tests. Cool. It's fun to be able to debug our tests in the same way that we can debug our actual code, because we can just look through it and get a feel for how that works. Oh, we've got this test failure. Let's see if we can debug that one. Let's set our breakpoint here and debug this test. F11. What is our time period? Our time period is afternoon. And if it's morning or noon, then we turn off. Oh, Our enumeration here says afternoon, and our code says noon. Hey, that's pretty cool. We were able to use our tests to be able to not only validate functionality, but also to be able to find bugs in our code. It looks like we need to change this to be afternoon, and now we can get that test to pass. Let's run this test explorer and see if our tests pass. Yep, now all of our tests go green. Cool. Isn't it cool to be able to validate our system, but also to be able to discover features of our system with these tests? Now, that did fix the bug, but I think the bug was not so much that we typed the name wrong, as much as we're using a string for an enumeration. Let's instead see if we can take a look at this and turn this into an enumeration. So here's an enumeration. I would like to say public enum time period, and I'll say night, morning, afternoon, and evening. That's great. Time period dot there, and time period dot, nope. Let me go grab this time period and set that in place there. And playing with the camera is always fun. the time period there, and the time period there. And instead of this returning this, it'll return a time period. And this returns a time period. That's cool. This now returns a time period. And will now match this to time period. And this one is time period. And apparently spelling is hard. And this one is time period. And so not only did we fix that bug, we fixed the notion of how that bug could come to be. Now that we're using a more intelligent mechanism here, we can see that it's never going to get the wrong enum value. There isn't a magic string to get wrong. That's cool. We could even take it a step farther and say, should we throw an exception if it's not one of these values? But in this case, it's comparing clocks, and so it's not possible to not get one of those values. Build, and that interface between our time period helper and the actuate lights code, that was just baked into this thing, so we don't have to fix our production code. There's nothing to change here in program.cs. But we do need to modify our tests a little bit because, well, we're passing in the time period here. So let's do that. Change that to time period dot there, time period dot there. And now we could even catch if we had a typo in one of our parameters. That's pretty cool. This one is a time period as well. And time period this one. And time period this one. Build. Let's run our tests. And what was really cool now is we had a lot of confidence going into this refactor that we weren't going to break things because we had all those tests validating the things. Did we break the, if I passed in motion detected, it set the current date time? No, because we have a test that proves that that's not the case. Excellent. So our next test, this to-do time period test, this will be kind of fun. We want to be able to capture if it's been more than a minute or less than a minute and see if it turns on or turns off. Let's come grab this implementation here and say, motion not detected long enough, turn off. And so now our test cases are inline data. I'm going to say 61 seconds should turn it off. And 59 seconds. Oh, GitHub Copilot knew where I was going there. Int seconds. Now, motion detected needed to be off. Actual turn off is false. The start time is datetime.now.add seconds. Seconds. The time of day. Here in our application code, we can see that if the motion is detected, we'll go this way. And if motion is not detected, we'll go this way. But if the time was morning or afternoon, we would turn off anyway. So let's not turn off there. Let's say var time of day equals dark, time period dot night. And now we've got our test that will be able to validate if we're within that window or not within that window. We do want to turn off if it's been 61 seconds and not turn off if it's 59 seconds. Let's run these tests. And we failed. What did I forget to do? Let's debug this. Debug test. I love that we can write tests to debug our code. You know, maybe we'll create a console app, or maybe we'll just launch the website again and click those 27 buttons, and that's not fun. But we can write code to test our code, and writing code is fun. So if we write unit test, we can have more fun. So the time period is night. That's great. If last motion time is greater than time span from minutes 1, and in this case it wasn't, last motion time is 10 seconds ago, and so it should be expected. That's great. Now we'll hit the other condition, where in this case the seconds is 61, and so now it has been longer than 1 minute, and that's going to elude me. My guess is that we have a race condition with timing, but I'm going to set that one aside. Call that a demo fail. I'll definitely debug that off screen though. Yeah. I might need to add a negative sign. Ooh. That is definitely the concern, because the future is definitely not in the past. Good find. Let's run that test. It's always easier to see from back there than up here. That's awesome. Good find. And then our test went green. Excellent. Negative is definitely a thing. When I was practicing, I put the negative there, and I did not do that today. Thank you for that. Cool, so we've got all of our tests to go green. This is excellent. Now, how do we implement this in our DevOps pipeline to be able to get at the test results as we're going? Well, I can come in here and I can say, here's the directory. I can say .NET build, and that will build the solution. We would then run .NET test, and that will test the solution. So let's go find all of the test projects, and now we see that we've got 13 passing tests, and that's great. But now how do we harvest those test results into something that we can show on our GitHub Actions dashboard? Well, what we can do is we can come in here and we can grab this JUnit logger. Now, typically we use JUnit when we're using Java, but it's just a standard reporting format. So let's add this JUnit test logger into place. I'll come in here to manage NuGet packages, and I'll add the JUnit logger, and I'll see actually that it was already installed. There's the oh, it's not actually installed yet. Nice. Let's grab the JUnit test logger. And once we have the JUnit test logger installed, when we run .NET test, we can say --logger is JUnit and log file path equals results dot test result dot XML. And let's go a little further and say collect xplat code coverage results. And so now, apparently I can't logger. Now we'll be able to grab these test results in a really elegant way. Cannot find a test logger with, because I need to first save the project. There we go. .NET build. Then I will .NET test. And now I'll get the test results in a really elegant way. So let's wrap that then in a DevOps pipeline. I can come in here into GitHub Actions, and we already have a workflow right now, but I'm going to hit new workflow just so we'd see how we'd get here. And now we can search for workflows. We can pull in things. I'm just going to grab a simple workflow, and that gets us started. This simple workflow just allows us to be able to run commands here. So here's a single line command. Here's a multi-line command. And so we could run those exact same things where we would say .NET restore, .NET build. Let's build in release mode. .NET test. And we'll say logger is JUnit. And we'll grab the other parameters. And then we could say .NET publish. And so let's flip over to the actual build pipeline here. Yes, I would like to leave. Here's that DevOps pipeline that we built. Just for the sake of time, here's in the done folder. And so we run the .NET test, passing in that file path, grabbing the results in this test results one. And then I'm going to take it a step farther and use this test reporter to be able to grab those test results and put them in place. So I'm going to very specifically do this if always. If we don't have if always, if the tests fail, they don't get published, that would be kind of a downer. So we will run that. And so let's come back here into our thing. And let's, the one piece I did want to show here is this. We have workflow dispatch. And because we have workflow dispatch, we have a trigger it now button inside of GitHub Actions. Where previously we didn't, we can come into our workflow and we can say run this workflow right now. If you ever committed a space or a carriage return just to get the build to kick off, and then someone's like, I'm totally failing your PR because you changed that file over there. Run workflow. Let's run it on the main branch. And it's going to do all the things. Let's watch it very carefully of all of the steps it's going to do. Well, first it's going to run .NET restore. And first it's going to find a build runner. There we go. Now it's going to run .NET restore. And then it will run .NET build. The build succeeded. Excellent. Now let's run all of our tests. And our test passed. But we also get this test report, which is great. It added this new tab right here. And so we can now see that here are our test results. We've got all passing tests. We've got timing of each test. And we're able to now gain a whole lot more confidence of our solution because we have these tests that will validate all of the scenarios within our application. Now today we just added a bunch of tests to a sample project, but it took us an hour to get from no tests to some tests. And that's my invitation to you, is go grab your project of choice and add some tests. Add those tests into the DevOps pipeline with the .NET test command and get to the point where you're now validating a little bit of your features. If you can get from 0 tests to 1 test, getting from 1 test to many tests is just a few more. .NET testing is really fun, and we can use .NET testing to be able to validate the features of our system. We can use it to debug the features of our system, and we can use it to find those bugs that we didn't even know was there. .NET testing is a lot of fun. Thanks for coming.